Welcome to our channel. Hi there, my name is Ranjan. I am a full stack DevOps engineer with 11.5 years of experience working in IT. I am also a 4.5 star rated Udemy instructor teaching more than 72,000 students worldwide. On this channel, my goal is to make you learn and grow by sharing my experience. So if you like my work, then do like this video, share it with your friends, and don't forget to subscribe this channel for more such awesome videos in future. So let's get started. Thank you. Welcome. What is blockchain? Before we try to understand what exactly is blockchain, let's try to understand how the regular web world works. So if you know how a regular web world works, then this particular picture would be familiar to you. Otherwise, let's quickly go through it. So you have a front-end application which is talking to a back-end application, or it is talking to more than one back-end application. And if it is a microservice architecture, each back-end application has its own database, and the back-end application can talk to a third-party service, and the different back-end applications, all microservices can also talk to each other. And you can have a front-end application that will talk to your back-end application with the help of APIs, which is RESTful Web Services, exchanging data in terms of JSON format, which is JavaScript object notation. Most of the time, the main functionality that we carry out in any website with this architecture is either user tries to log in, which is a select query, or user tries to see the details, which is again select query. User tries to update some information. User tries to create a post. So update information is an update query. Creates a post is an insert query. And sometimes user deletes the post. So that's delete query. So most of the time we as people or consumer of any website are doing these four operations. And that is happening on a particular database around the world on the internet. So this is how the regular web world works. So the front end can be basically in any technology, React, Angular, Vue.js, or it can be normal JavaScript. And there's a front end developer, and similarly there's a back end developer who is writing code in the Node.js or Java, Python, .NET, PHP, doesn't matter. And in case of microservice architecture, you can have different backend components written in different technologies. And they can talk to different databases. It can be a NoSQL database or it can be a SQL database. Doesn't matter. So all in all, this is what we are acquainted with. This kind of application development, this kind of application usage. But there is one inherent problem with this particular approach. The data that is going here is centrally owned by the company for which this particular application was built. Let's say you are using a bank website, or you are ordering a pizza, or you are using an e-commerce website. The data inside the database is owned by that e-commerce company. The data inside this database is owned by that bank or insurance company or the e-commerce company. The application is also owned by the company. So you as an end customer are not even owner of your own data, which you have used for registration and sign up and ordering purposes. That data is also owned by the company who is owning this application. So there's one big problem with this kind of web application that we have right now. Next to that, if you want to do transactions in the bank account, then you have to pay some charges to the bank because The bank is taking guarantee that your money is safe in that bank account, and then whenever you do a transfer of the money, that particular money will reach to the right bank account. So the bank is basically taking care of it for you. And how? With the help of this kind of technology setup. So the money that the bank earns from there invest in this kind of technology IT costs. But then this is, if you see in a very nutshell, this is a centralized database, centralized application. And let's say there are different companies. A bank website wants to talk to an e-commerce website. So of course they have their APIs open, they can talk to each other. But still, they are centralized companies. They own data centrally, they own application centrally. At any point of time, if they want, they can change the data here. They can take this data and use it for any purpose which we even might never know because we don't know how they are going to use our data. Similarly, in the application, if they modify anything, we don't know what has been modified. So that's a big disadvantage in the today's regular web world, which is centralized and owned by few companies across the world. So let's say if we start counting which are the top 5 companies that owns the majority of the data in the world. So we can say Google, Facebook, Facebook via Instagram, WhatsApp and Facebook application, Google via search engine, Gmail. Just if we say Amazon, which is an e-commerce company, then we got some banks or insurance companies. So these are some big companies which hold majority of the data or majority of the customers' data around the world with them. So it's kind of centralized uh, within this 4 or 5 or let's say 10 companies around the world. The whole world's data is centralized around this, which is not a good idea. Anything can happen in future. Just based on trust, we trust and we do this. We use the application. It doesn't mean that nothing can happen tomorrow, nothing can go wrong tomorrow. So there was a need felt for avoiding this kind of central data storage or central application usage system. And that's where blockchain was developed, which basically works on the idea of no intermediary, no broker, no centralization. So blockchains are distributed. Blockchains are not owned by any company or any entity or single person. Changes to the blockchain cannot be done right away. Changes to the blockchain needs permission from many parties. Changes on the blockchain cannot be deleted. On the blockchain, changes can only be inserted and read. You cannot update any data on blockchain. You cannot delete any data from blockchain. On the blockchain network, two people can talk to each other directly without the need of any intermediary. If you want to send money to someone else on a blockchain, you can directly do that without the need of a bank. So that's how blockchain differs from the regular web world. Let's continue our discussion about what is blockchain in the next video. Thank you. Welcome. Now that we know why do we need something like blockchain, and we also now know what are the disadvantages of regular web world. So let's go ahead and answer the question, what exactly is blockchain? So what is blockchain? Blockchain is a system of recording information. in such a way that it makes it difficult or impossible to change the data, hack the data, or cheat the system. So this line speaks for itself. Blockchain is a system where you can record information or data. That's what we do in the database also. But here what is different is in the blockchain it is difficult or kind of impossible to change the data. Even without hacking, with hacking also you can't change it. And there's no way that you can cheat the system. So let's go further and understand what exactly and how it exactly does. A blockchain is essentially a digital ledger of transactions that is duplicated and distributed the, over the entire network of computers on the blockchain. So let's go ahead and first understand what exactly is a ledger. So if you maintain a diary where you write all your expenses of every day, the diary itself is a ledger where you are maintaining what did you spend today for grocery, how much did you spend today for food, how much for travel, how much salary did you receive today, how much bonus you received, how much you earned in stocks. So what you are doing in the diary is writing how much was your expenses, how much your savings, how much your was your income. So this records that you are writing in the diary is nothing but a ledger is that you are maintaining, and each entry is a transaction. I spent $15 on a pizza. So this is a transaction in the ledger. I earned $500 with this stock. This is another transaction in the ledger stating a positive entry. So now you know what exactly is a ledger and what is the transaction in the ledger. So let's try to read the statement again. A blockchain is essentially a digital ledger. So it's not a diary. Blockchain is a digital ledger, which means it is maintained digitally on the internet. But this ledger also contains transactions. Alright. And these transactions or this ledger or the transactions in this ledger is duplicated and distributed across the network of computers on the blockchain. Alright. So now let's come back to the example of the diary. Let's say now you are making an entry in your diary about the different transactions that you did. So if you have that diary, you can do the modification anytime. But what if I make 10 copies of that diary and give it to 10 people? And now if you want to do a modification, of course you can do the modification on the copy that you have of the diary. But then 9 other diaries are still not updated, which means the transaction that you did on your ledger, on your copy of the ledger, is not going to be permitted. So if you have to make sure your transaction gets permitted into that ledger, then you have to make sure all other 9 distributed diaries or ledger get updated with this transaction. So what you have to do? You have to go to those 9 other people and tell them, hey, I want this transaction to be added to that ledger. And this transaction was about I bought a, let's say, a cold drink today, a bottle of cold drink today. So I spent $10 on that. So you want this legitimate transaction to be added there. So all the 9 other people are going to look at your transaction and they are going to say, all right, let us validate whether this transaction is valid or not. And they will ask you a receipt or the bill for that particular transaction. So if you are able to show them that bill or the receipt, they will verify whether the bill is genuine, authentic or not. If that is authentic, all the nine will believe you and they will write the transaction in their local ledger copies. But let's say even one person also out of that nine says, no, I don't agree with this, then your transaction cannot be part of that ledger. Similarly, it works in the blockchain world. Only difference is here the blockchain is a network of computers, not network of people, but network of computers. And on this network of computers, there are some logic written to validate a particular transaction. So whenever we want to get a transaction entered in this distributed ledger over the network of computers, those computers are going to make sure they will validate this transaction, and if they find this transaction genuine, they are going to update their ledger. So that's how it works, and this is what it means with the first statement. Now let's go with the next part. Each block in the chain contains number of transactions, something like this. So this is a block which contains multiple transactions entries. And every time a new transaction occurs on the blockchain, a record of that transaction is added to every participant's ledger. So every participant is holding a ledger. So whenever a transaction is happening on the blockchain, it is getting entered in that particular ledger as a new entry. That's what it says here. The decentralized database managed by multiple participants is known as distributed ledger technology. So the decentralized database, which means in our example, the network of 10 people holding each local copy of the diary where you were writing the transactions, that distributed network itself is called a DLT, distributed ledger technology. That is acting as the total of 10 diaries are acting as a decentralized database, which is different from the centralized database where it was easy to update the data. But now in the decentralized database, it's not at all easy now to update the data. So now, if any transaction needs to happen, it should be first validated with the other parties in the network, and then only that entry of the transaction will be added to the distributed ledger. So now let's say one block is full because every block has a limit to which the number of transactions can be added. Let's say one block is full, then a new block will be added and then the next transaction will be entered in that new block. Similarly, the subsequent transactions will be added to this particular block until this is full and then another block will be added. So this series of block where each block contains transactions, this series of blocks are connected to each other is called a block chain. That's why you say block chain. It's a blockchain. So it's a series of transaction entries or ledger in a block, and similarly multiple blocks form a chain, and that's called blockchain. So now if we go to the last part, it says blockchain is a type of distributed ledger technology in which transactions are recorded with an immutable cryptographic signature called hash. So these transactions, when they are recorded, it will be recorded with a cryptographic number, a big number will be generated for that transaction, and that transaction, the cryptographic number, will be added to this block. That's what it means by the cryptographic signature called hash, and that cryptographic signature for that transaction is called hash. So now you understand what is blockchain, what is distributed ledger technology, and what are the benefits of blockchain. You cannot change the data, you cannot hack the data, you cannot cheat the system. It is a distributed database, decentralized database. It is a network of computers. It records transaction with cryptographic signature called hash. It forms series of blocks with transactions that's called a blockchain. So this was about blockchain. I will see you in the next video. Thank you. Welcome back. It's time for us now to discuss about some of the features of a distributed ledger technology or a blockchain. So here's a picture which talks about different features of a blockchain. So let's quickly talk about them. So number one is, if this is our blockchain network, then we can say a blockchain is a programmable component. So in the blockchain, we can write programs that we are going to look into in the upcoming videos. But for now, just remember, we can program a blockchain. We can tell the blockchain what it needs to do. So that's what it means by a blockchain is programmable. And the way we program the blockchain is with the help of smart contracts. We write a piece of code which will run on a blockchain network, and that piece of code is called smart contracts. That's it. Next, blockchain is distributed. All network participants in the blockchain have a copy of the ledger for complete transparency. This is what we discussed. The data itself is distributed. It's a decentralized database. So every participant of this network or every computer network or in the network has a copy of that ledger, and this makes it transparent because no one can modify it without the consent of others. Next, in blockchain everything is immutable. What it means is you can basically only add data to the blockchain and read data from the blockchain. You cannot delete it, you cannot update it. So make sure whatever changes that you are doing on the blockchain with the help of your smart contracts, you are sure about that change because it is not irreversible. It is irreversible, which means it cannot be reversed. So you have to be sure what you are writing and what change you want on the blockchain. So that's what it says. Any validated records are irreversible and cannot be changed. You can do another transaction, but that transaction will be different from this previous transaction, which means let's say transaction 222 was once entered, that cannot be updated. You can do another transaction 333 on top of 222, but you cannot modify 222. That's gone. You have to remember this. That's the immutable part of blockchain. Then time stamped. Every transaction that goes into a block inside a blockchain gets recorded based on timestamp. So when this 222 transaction took place, the time will be also recorded so that it is easier to trace back when a particular event happened on the whole blockchain. Next is unanimous. All network participants agree to the validity of each of the records. That's what we also discussed in our example of the diary. If you want to modify and something in the diary, you cannot delete it. you cannot update it. So you have to have another entry. But that entry you can only do if other participants, other diary holders agree to it. And for that, you have to reach out to all of them, and all of them unanimously should agree to this change. That's what it means. Anonymous. So now we say that the identity of the participant is either anonymous or pseudo-anonymous, which means, let's say in the example of our diary, the 9 other diary holders can choose to either disclose their identity or they can choose to remain anonymous, or maybe they can just say that they will not tell you that they are the direct owner of the diary, but they have allocated somebody else to become the owner of that. So it's kind of pseudo anonymous. Same way, the computers that are participating in this whole blockchain network can remain anonymous. You cannot and still do the transactions on this particular blockchain. Next is secure. All records are individually encrypted. That's what we said. On the blockchain network, every entry or every record that is getting added is cryptographically signed, and that's called a hash. And this is done with the help of very complex algorithms. So it is very difficult to crack those signatures. So if somebody hacks to the blockchain also, these cryptographic signatures are very difficult to crack. That is what it says. It is very secure. All records individually are encrypted and secure. And we are back to that a blockchain is programmable with the help of smart contracts. So let's go ahead in the next video and look at what exactly is smart contract and how can we program a blockchain. Thank you. I will see you in the next video. Welcome back. Let's go ahead and understand how can we write programs and execute on a blockchain network. So if you remember from our web development world, when we wanted to execute a front-end code, this front-end code runs on the browser. So browser is making sure that it runs this front-end code. If we wanted to run a backend application written in Java, so we used to install Node.js. If we want to run a backend application written in Node.js, then we have to install Node.js because it runs JavaScript on the backend. So for JavaScript on the backend, we want Node.js to be available. But if we want to run Java on the backend, we need a Java virtual machine, which is JDK, we need to install. Same for Python, we need to have a Python runtime and install for .NET and PHP same way. Similarly, if we want to run a smart contract, we need somebody to run those smart contract. So that's where we have EVM, Ethereum Virtual Machine. So there are different kinds of blockchain, but we are focusing on learning Ethereum blockchain. And the runtime environment for Ethereum blockchain is EVM, Ethereum Virtual Machine. And what Ethereum Virtual Machine is, it just understands bytecode 1010, something like that. But we as a programming developer who wants to become a blockchain application developer, right, who wants to write DApp, DApp stands for distributed apps. Like we have apps for normal web application, we develop apps. But when you write apps for a blockchain network or a distributed ledger technology, then the same apps is called dApps, DAPPS. So in order to become a blockchain developer, blockchain application developer, let's call it that way. If you want to become a blockchain application developer, then we need to learn a programming language called Solidity. And with the help of Solidity, we can write smart contracts, and these smart contracts can be compiled into bytecode and then executed by the EVM. And as we know, this EVM is a big decentralized database which not only holds the data but also keeps these smart contracts applications in on itself. So whenever we want our smart contracts to be executed, as a blockchain developer, we have written a smart contract and it is already deployed on the Ethereum network, let's say Ethereum blockchain network. Now, what should happen when this will get executed? If this smart contract will get executed, that part we have written. So let's say something should happen when this gets executed. That part we have written here and it is stored here. So now we have to call or invoke this smart contract so that it executes itself and does the desired action that we wanted. And that's where we need to communicate with this Ethereum blockchain or any other blockchain for that matter. We need to also communicate with it so that we can invoke this smart contract so that it can execute itself. And that's where we have libraries like Web3.js or Ethers.js. These JavaScript libraries helps us to interact with our blockchain network and invoke one or more smart contracts so that those smart contracts gets executed on the blockchain network, and then those particular effect will occur automatically. And finally we have the front end. So the front end developer can basically continue to write front end as usual, and whenever they want to do an effect on the blockchain network, they can call via the Web3 API, and then that effect will be taken or executed here. So if a blockchain network is being used by a application, it does not mean that this application cannot have a backend in Java, Node.js, and it cannot have a central database. It can. So one thing to point out is this is smart contracts when you deploy on this network and when you try to execute them, you have to pay something to this network because this network is a series of big computers. So these computers running on energy, power, electricity. So if you don't pay anything, you cannot execute here. And if there was no cost of execution of the code here, then anyone can put some junk or garbage and start execution here, and that would kill the network or cause bugs in the network. So what they did is they introduced a fees called gas fees. Whenever you want to execute your smart contracts on the network, you have to pay some money. Right now, the gas fees is quite high for Ethereum, but there are other blockchains with cheaper gas fees like Solana who charge very less and also are faster. But of course, Ethereum is a bigger ecosystem and a lot of things are being already done or are in progress to reduce the gas fees cost and also increase the transaction speed, transactions per second. So for now, just remember that A smart contract is not getting executed on the main network of Ethereum free of cost. Of course, there are test network of Ethereum where you can execute your smart contracts with dummy money. Dummy money means those are just dummy gas amount that you will get, which you can use to test your smart contracts. But when you want to bring the smart contracts and execute on the main net, which is the main network of Ethereum, you have to pay real money in dollars, which acts as a gas fees. And only then your smart contract will get executed and it will bring the effect that you wanted. So it is also very important to understand what you should keep on a blockchain network and what you should keep in a normal centralized database. Because anything that you keep or want to get handled by a blockchain network is going to cost you money. So I can give you one example. Let's say you want to you own a land and now you want to sell the land to somebody. So this is a perfect use case where of data that you can keep on a blockchain network because you know that one land should have and must have one owner. But then if people are trying to do forgery, what they do is the same land gets registered to many people multiple times. So the land registry information can be added on a blockchain network, which means no one can modify it. And a new entry can be added only when the transfer of ownership will happen. And when the transfer of ownership will happen, it has to be validated from many computers in the network, which means it will be very transparent at any point of time who is owning that piece of land. And you can also trace it back and see who was owning that land in the past because blockchain network keeps the history also. So this is a good example that you can keep that piece of information, the land ownership piece of information on the blockchain network. Other things you can keep on your normal database. So you have to think smartly what should go on the blockchain network as a part of your smart contract and what should go into your regular database to avoid the cost. And of course, these things we already talked about that EVM only understands bytecode. You can only insert data and select data because this is all immutable and this is a distributed database which also keeps the code which will get executed. Usually in the database we just have the data, but on a blockchain network we also have the data plus also the application code which are nothing but many smart contracts. So there can be more than one smart contracts at any point of time on a particular network. Remember we just talked about the Ethereum blockchain, but this concept is valid for any other blockchain. Just that for Ethereum blockchain, we have to use Solidity as a programming language, but there are other networks of blockchain networks where you can use some other programming language to program. So let's quickly go through this definition of smart contract. So what it says, smart contracts are simply programs stored on the blockchain that run predetermined conditions are met. So these are programs, they are just stored on the blockchain network and they will only get executed when a predetermined conditions are met. And the smart contracts are typically used to automate the execution of agreement so that all participants can be immediately certain of the outcome without any need of intermediary involvement or loss of time. So when can you go? You go for this kind of smart contracts or blockchain. Let's take our example of the land purchase history or land ownership. So there we need to have if we wanted to have an agreement that who owns that land at a particular point of time, and it can be proved at any point of time that who is owning the land and who was owning the land. So that's an agreement we want to make without the involvement of any third party or intermediary and without even losing time. So this kind of things we can use blockchain and smart contracts. So they will avoid intermediary and they will also avoid time loss, and still we can have very transparent way of handling agreements between the parties. So this was all about how you can write piece of software and execute on a blockchain network. In our case, Ethereum blockchain network, which can be of course a main network and a test network. So in the upcoming videos, we are going to explore further the Solidity programming language and how to write smart contracts with the Solidity programming language. Thank you for watching this video. I will see you later. Welcome. Let's go ahead and learn the programming language Solidity so that we can write smart contracts for our blockchain network. So now, in order to learn any language, we need an editor where we can basically use the editor and hook up the runtime, which can be a compiler or an interpreter, which is going to compile our application. So in order to learn Solidity, what we will do is we will take help of this online editor called Remix. And if you go to this website called remix.ethereum.org, you will get a browser based online editor. And it is good enough for learning the Solidity programming language. Later on, when you will build projects, then you will need more complicated IDE and some frameworks. So once you are on this screen, you will see, of course, you will get some pop-ups about agreeing to the license and those things, accept those. And then you will see three tabs. One is this File Explorer, then this is Compiler, and this is Deploying. So now if I go ahead, you can see this, there are different options. So you can create multiple workspaces here, but we'll go with the default workspace. Let me create a folder here saying, let's create a folder inside the contracts. We will say learn. I will hit enter and we are going to create our first Solidity file. So click on this or right click here. So click on new file. Give the file name here. So I will say data types, hit enter. So it's going to automatically add the dot sol. So I'm going to zoom a little bit to the browser window so that you can see it properly. So it will add dot sol automatically. Ignore these other Solidity files which was already available. So now in this dot sol file, which is the extension for any Solidity file, like in JavaScript we have .js, Java we have .java. Similarly, .sol is the extension type for Solidity. So every Solidity file we should have a header called pragma. So type pragma and type Solidity. And now here we can say which version of Solidity should this compiler use to compile our code. So let's go ahead and define that here. So I can define it in two ways. One is I can go with the range like this, like 0.8.4, 0.9.0. So I can use this range. Within this range, the compiler can use any version of Solidity for compiling. Or I can also go with a specific version of Solidity that the compiler should use for compiling this program, this particular Solidity file. And that I can do by specifying a caret, which is on your keyboard a top arrow sign. So I'm looking for my keyboard now where I can find that caret symbol. So it's above the 6. So this symbol, if you give, and then it is going to use a specific version of Solidity to compile. Next, let's go ahead and put a semicolon. You should always terminate the statement with semicolon in Solidity. Now, in Solidity, we write everything inside a contract. So let's say I'm going to create a contract here called contract is a keyword, and then I will say the contract name. Data, I will say data type contract. Opening bracket, curly bracket. So if you remember, we create classes like this or structure with the struct keyword or class keyword. We give the name of the class, or struct keyword we give the name of the structure. And inside that we can define different data types and variables. So let's look at what is the first variable that we want to know. So let's go with unsigned integers. So we have unsigned int, and this is how you declare variables. So first you say the data type, which is unsigned int in this case, and I will say num8 equal to, let's say, 4. So it's going to give a semicolon, so it's going to save 8 byte long number, but it cannot be negative. It should be always positive. I cannot put this. It should be always positive. Next one that I have is, it's not remove this. It should be u int 8. Similarly, I can have u int 16 to have a longer number, but still it should not be negative. So I will say, let's say something like this. I also have even longer one with u int of which is unsigned int of 256. It is going to be quite long, so it can hold a huge number, let's call it that way. If I by default use just u int, then it defaults to number 256 size only. It's that default to that much, which means it can also hold 256 in length. Can I use a negative number? So yes, for that the data type we should use is int. Then it can have neg pos, any kind of data, negative or positive. So I can say like this, or I can just say like this. But remember, the range will reduce the data that we can store. So next is, if I go with int 256, then of course we will get a bigger range neg pos that we can store. So these are about integer int data type or negative positive data type. Similarly, we have other data type like boolean. So in the boolean we can either have true or false value. So we can say either true or it can be false. So we also have other data types that we will look into. But so far you might already know that these kind of language which has specific type defined, they are strictly typed or statically typed, which means be there has to be a data type before this variable, and then this, if we don't store the value according to the data type, we will get errors. So this boolean, if I want to make it as a constant, so I can just say constant after the data type, and before the variable name I will just put constant, which means I cannot change the value of t or of this variable's value further in the program. If I will do like this, I will get an error because I already declared it as a constant. I cannot change its value. So this will give error as we are changing the value of a constant. Alright, so these are some data types. We also have other data types. Let's look at them in the next video. Thank you. Welcome. Now let's continue further with other data types. So let's talk about string and arrays. So here in the learn, I'm going to just type new file and say string and array. I will hit enter, and again I have to grab the pragma solidity, and let's create a new contract, say contract. So if you scroll down, it will automatically suggest you. So we say contract string and array. So let's say arrays. So I can define a string like this here, string, and then I can say name equal to, I can say John. But what if I have to define more than one string? Then I can say string, declare it as an array, and then we say names array. And then I can go ahead and initialize it like this. Apple, mango, let's say banana. Similarly, you can add more. Now let's say I want to run this and see how it works. So let's go ahead and do that. So what I'm going to do, in order to run your Solidity smart contract, what we have to do is come here in this compiler, Solidity compiler. As we have chosen this version of Solidity, so make sure you use that. So from this drop down of the compiler, we will choose this particular version, and keep the rest of the things same. And you see here it says compile string and array sol. So that's our file. So click on compile. So it's compiling that. And it did compile that. Of course, we have an uh, warning. We can ignore that. Now if we go here, it has already compiled it. That's fine. Next we go to deploy. So here is what we will deploy our Solidity smart contract, which is just compiled onto a test network. So from here, you see I have a gas limit of this much. This is just fake Ethereums, which I am going to use for deploying my smart contract onto the test network. So this will be using limits from here. So let's go ahead and deploy our smart contract. So here you can see many contracts. So here is my one contract which just got compiled. I'm going to click on deploy. So here below you can see some logs. These are the logs that it will give you while deploying this data. So now once you click on deploy, you will get this and it says it's deployed. Now here under this need you can see deployed contracts. Click on this and we see that our transaction has been successfully deployed. But what if I want to interact with this name array? Maybe I want to get the value of mango. I'm not able to access it. That's where I can use public here. So in between the data type and the variable, I will use public. Now I modified my contract, so I have to go back in the compile. With the same compiler, I'm going to compile it again. So it has compiled it. I will go back and I will see the smart contract and now I will deploy it again. So it's deployed. So now if I go to the deployed smart contracts, which is this one, here I will see this, it says name array. So here let me specify the index of mango. So it says 0, 1. So if I specify here 1 and click on this, so I will get mango here. So what happened is it went to the smart contract and invoked the smart contract on the Ethereum test network. And once the smart contract was invoked, what we wanted is the first value from this array. I mean the first index 0, 1, 1th index value. So 1th index value was mango, so we got the data. If I want to do it again for the other one, I can do that. I don't have to run this again because it's already compiled. So what I have to do is I just go here and I will say 2 index. And you see the same smart contract which is deployed is getting executed again and I got banana here. So this is how we can basically compile, deploy and execute our smart contracts on Ethereum network. And if you see, we are getting here, we are basically say we are a user who is executing this, and this is the address of us. So now, if we make something public, we saw that it is accessible to anyone on the network. So only make things public if you want those things to be available on the network to everyone. So my now names array can be accessed by everyone on the network. So now we just saw an example of making a string array. Can we make integer array, number array like other data types? Yes, of course. And the way to do it is the same way as we did. So if I go here, I can just say here like this. uint of array num array equal to, and then I can start adding some numbers here. By default, this will be of 256 because we did not mention any type here. So this is an unsigned integer array. Similarly, we can define arrays for the int, which can be signed negative or positive. We can have booleans, we can have string that we saw. So this is it for this video. Thank you. Welcome. Let's go ahead and learn about how can we create our custom data type, because in any programming language we need to store our custom data type as well, objects related to our custom data type. Let's say employees, let's say department, product. These are custom data type. These are not provided by any programming language. So let's look at how in Solidity we can achieve that. And we are also going to create function. So I will go back to the Explorer here, and in the Explorer, ignore these files that are getting created, because these are the files which gets created when we do a build of our Solidity contract. And this is how the compiler handles the compilation and deployment of our contracts onto the network. So we go to the learn folder and create another file called, this time we give the name of the file as struct and function. So we are going to learn about how to define structure and functions. So I'm going to copy the pragma, paste it here. By the way, from here also you can zoom in and out of this section, of this code section. So now what I'm going to do is I'm going to define a contract again. So I'm going to say contract, and I'm going to give a name to it. So I will say struct, and always give the name in capital letters. Follow the normal naming convention of a class. So start with the capital letter. So I would say struct func contract, something like this. And inside this, we are going to define our custom data type. So let's say define the custom data type. And this is a single line comment which basically does not get execute. So this is just for informational purposes. Uh, the compiler is going to ignore it. So let's go ahead and say struct. So start with struct keyword and give it a name. So let's say I'm going to define product here. And then what we are going to do is just follow the normal variable declaration that we do. So first thing is string. So I will say product name, then another string. I will say category, something like this. And then I will go with int and I will say price, and maybe let's say the u int of 16, and I will say code, something like this. So this is our product. Now I want to declare a variable of this product and I want to use it outside. So how I can do that? So let's go ahead and do that. So here I have to first define a function. So I'll say function, And in this function we are going to access the product data. So the way we define the function in Solidity is similar to what we do in JavaScript. So if you know a little bit about JavaScript, this is what we do in JavaScript. We just say function, and while declaring the function we basically use the keyword function. And what I want to do in this function is I want to basically assign a value to an instance of the product. So let's go ahead and first declare an instance of the product. So I will say product, and I will say product, let's say. I can also create array of products like we do with the normal data types. I can also do with custom data types. So I will say product and give the name of the product as laptop. And I want this product to be publicly available. So I will say public here as a keyword. Now I am going to go ahead and create a function. So let's say I will give the name of the function as initialize initialize product, and this function I will make as public so that I can access it from outside. I have not passed any parameter to this function, but we can also pass parameter to this function, like I can say uint and then pass the value here, then comma, another value, like that I can pass. So now what I want to do is I want to say I want to initialize laptop. So I will copy paste here laptop equal to, and then I will just say product, and we will have to initialize the data of the product. So how do we do that? So this is a constructor that we are calling. Constructor is something that is same name as the struct, and it basically takes some data. So here we will pass an object, and this object will be very similar to a JSON object. JSON means JavaScript object notation, and which this JSON object is nothing but a comma separated key value pair. So let's go ahead and start defining our JSON. So I will say first variable product name is of type string. So I'm going to say Acer laptop. I'm going to minimize this so that it is visible. And so we defined our first variable key value pair in this object, JSON object. Second one will be a comma separated, and the second one is category. We'll say category as electronics. Third data is price. So I'm going to say price. And this price will be, of course, of type int, which means it can be negative, but usually price are not negative, so it doesn't make sense. So I'm going to make it as uint. And of course, price, I'll make it as 16 to be memory efficient. So now the price can be, let's say, something like this. Then we have the code, and code will be I will give some random number here. That's way. So this is we defined one laptop, and we defined a function in which we are initializing this laptop. So in this way we can declare our own custom data type, and with the help of struct, and we can also declare functions. In that function we can do anything what we want. We can initialize data, and if we make this as public, then it can be accessed from outside. Anywhere in our network we can access this public data. Let's go ahead and compile and deploy this particular contract. So I will go to this and then I'm going to say choose the compiler, that's correct, and then I will say compile struct func solidity. As soon as we do compile this, we see an error, and there's a reason why there's an error. So it complains about this value that we are using for price. So one thing to remember is that in Solidity we don't have any place for or any data type for storing decimal value. So we cannot store decimal value in Solidity. Remember that. The reason we got this error is because here in our product we are using, if we use a decimal value like this and compile, we will get again the error. See, that's the problem. So if we get rid of this and compile again, the compilation passes and there's no problem with this. So the thing is, if you provide bigger number also, which increases the size of this capacity of this u int 16, or then also you will get the error. And if you use as decimal value for price, then also you will get error, because Solidity does not support floating point or decimal value, those kind of things. You need to handle it differently, but Solidity or the Ethereum blockchain does not support that kind of formats. Alright, now that it is successfully built or compiled, so let's go ahead and deploy this. So let's go to this and click here deploy. Make sure your smart contract is selected. So click deploy. So here is our latest deployed smart contract, and here we have the contract. So let's click on initialize function because this is public, so it can be accessed. So click on it, and now I will click on the value of laptop. So this has already initialized this, so we should get all these values now. So there you go. We see the product name as Acer laptop, category electronics, price this, code as this. So this is how you can define your custom data type in Solidity and also declare functions to initialize or do any operation that you want on this data, and then you can access them outside. Do remember there is no floating point data type in Solidity. So let's write it down. Solidity does not support float data type. So this is it for this video. Thank you for watching. Welcome back. Let's talk about address and mappings in Solidity. Before that, I would like to show an example of multi-line comment. So here we saw a single line comment, and we know comment doesn't get executed. So how do you do a multi-line comment? So this is an example. It's similar to JavaScript, where you put slash star star slash and put all the things that you want to comment in multiple line. So this is how it works, and this piece of code will not get executed. Having said that, let's move on and see how does a address data type work. So if you remember, we ran our program so far and we saw we are getting this kind of addresses, and this is an address. This is an example of address, and we sent the input from this address. So these are long strings from and to address, if you see, and at every address you basically can have a basically a smart contract that can exist at the address, or a particular wallet can have an address. Wallets are like in cryptocurrencies or in the token world, they hold some balances or some amounts. So let's go ahead and see how to work with addresses. So here I am going to create a new file called address and mapping. And in here what we are going to do, again we are going to copy the pragma header and put it on the top, and we say contract address and that's a mapping. This can be any name other than the file name also, or it can be same as file name, doesn't matter. And now if I say, let's say address user 1, let's say I'm creating an address of a particular user. So if I go here, my compile, I will see, or in the in the deploy, I will minimize this. If you scroll up, you will see there are many address linked to this. So there is an ether, there are many addresses, and in each address there is some ether. Ether is the token of Ethereum network. So when we are running our smart contract on the Ethereum network, we pay to the network as a gas fee or in ethers. So this is the account with which we are basically accessing we are using the ether from this account. So what I will do, I will click here as copy, and I will go to the program and paste this particular address here and put a semicolon. Now what I want is, I basically want to see, I want a scenario where I want to see but balance at a particular address. So what I want to see a balance at a particular address. So we know that in if we declare a type of an array, then we can basically have similar kind of data in an array form, and with the index we can access it. But if we want to do something like that, like this, like we pass an address and we should get the data stored at that address, it's like a key value pair, then we have to use something called as mapping. So what I will do, I will create a mapping of, you have to put like this parenthesis, and I will say on this particular address you should store a uint value. That's what I'm saying here. So what I'm saying here is, at a particular address store an uint value. So when I pass an address, I should be able to get that value. So now I will make this and declare a variable. So this is also a type. This is also a data type. This is a address data type. We know int data type, unsigned int, float, string. Also we saw struct to declare the custom data type, and we saw arrays. So similarly, this is also a data type, mapping of an address with uint. And I'm going to say balance. So this is a variable which will store the value of the balance. But I will make this as public because I want to access it from outside. So now we need to create a function to get this balance. So I will say function get balance, and I will have to make this function as a public function. So I'll call this as, make this as public, and then I'm going to say balance at the particular address, balance at the particular address, like for the user one, I will initialize with, let's say 150. So what I'm saying is assign 150 as the value on this particular address, which means it's going to come here in this mapping variable, and at this particular address, which is this one, this particular big address, it's going to assign a value of 150. So now let's go ahead and compile this. So I'm going to go here. It's this compiler. I'm going to compile it. So there's no error. That's good. So it compiled successfully. Now we go here and we will deploy this. So this is the one. So let's go ahead and deploy this. So here the deployment went successful. So let's check our deployed contract. So this is our deployed contract right at the bottom. So click on this, and here we have the get balance. So if I click on, before getting this balance, I need to put the address on which I want to get the balance. So this is the address, right? So I will copy this address and I will pass it here as an input, and then I will say get balance. As soon as I do this, you see it receives the request, and let's expand this, and I'm going to make a call, and you will see I will get value as 150. Same value, when I make this get call, it assigns this value here at this balance, and then when I do this, it gives me this data 150. So if I change this to, let's say, 170, I just have to go back and compile my program, come here, and I have to deploy the updated smart contract, and then I have to go to the latest instance of the deployed smart contract, which is this one. I have to pass the address. I have to click on get balance, and then I have to click on balance here. As soon as I do that, the get balance call assign the value, and balance, when I clicked, I got the data fetched, which because this is the public one. So what if I execute the other one, previous one? So if I do get balance and I do balance here, so I still get 50, 150. What this means is that the same smart contract is now deployed on different addresses. So on the same blockchain test network of Ethereum, multiple instances of our smart contract is running. So whichever instance we invoke, that is the functionality it will execute. Hence, it is very important that before deploying a smart contract, we should test our smart contract thoroughly. Otherwise, we are going to deploy a buggy or smart contract with issues on the network, and you know that once you do anything on the network is not going to be changed. It cannot be deleted or updated. So always we should test our code of the smart contracts before deploying to the network. Otherwise, you are going to deploy a buggy software, and then when you deploy it, you execute the command, and then you also have to do pay. You have to do the payment in ethers. You have to pay the money or the gas fees on the real network. Hence, it's going to become very costly for your company. So always write bug-free code, test it thoroughly, and only then go for deployment on the main network of your blockchain. Thank you. Welcome back. Let's go ahead and talk about constructor and functions. So I'm going to create a new file here. call constructor function. In here, I'm going to just go ahead and type the pragma part. So I'm going to say pragma solidity, and let's go ahead and give the version. We can use any version, but let's use the version which we have been using so far. So 0.8.4. Create a contract. Cons fun. Let me call it this way. And what I'm going to do is I'm going to create a variable with data type of address, and I'm going to say owner. That's a variable name. Next, I'm going to create a constructor. So in order to create constructor, we have to just type constructor, and this is a special function which you cannot call outside, and this will be called once whenever our contract gets deployed on the chain, on the blockchain. So special function that cannot be called outside, that's number one. It's called only once when the smart contract gets deployed on the network, on the blockchain network. All right. So whatever code that we want to execute on the load, on the execution, on the start of the execution of this block of this smart contract, we should put that particular code here. So what I'm going to do is I'm going to say the owner address, which is at the top, it should be initialized with message dot sender. All right. So let's say here what will happen, whatever is the value of message dot sender will be initialized here. But now we need to understand what does this message dot sender hold. So it holds the address which is used to deploy the contract. So whichever contract we will use, or whichever account that will pay the gas fees for deployment of this contract, that particular account's address we will get it from here. And what we are saying is we are assigning that particular account's address to this owner. Now let's go ahead and create a function that will change the ownership. Change ownership. So whenever we will call this function, it's going to change the ownership to something that we want. So we will pass the address of new owner. So this is how we pass a parameter to a function. So we can pass multiple parameters by giving comma, but this is how we pass parameters to the function. Now what we want to do is we want to basically access this function from outside. So I'm going to make this as public. And I'm also going to access this variable from outside. So I'm going to also make this as public. When I say outside, which means when I run this particular smart contract on the blockchain, I want to interact with my smart contract. And that's where I will call this method and also this variable. Okay. Now what I want to do is I just want to say owner equals to new owner. That's what I would say. But before that, let's say I have to add a validation. So how can we add validation? So here we have a method called require, where I am going to say if the owner address is equal to message dot sender address, then we are going to return an erroneous message and the whole transaction will be rolled back. So we'll say only the owner can change the current owner. So if we want to change the current owner to someone else address, then it can be only done by the current owner. So what we are saying now is the person who is deploying the contract, we are storing that value here, right? On the initialization. Now, whenever we are changing the address, we are checking whether the person who is deploying, is it the same as the one which for the first time deployed it. If that's the case, we will show a message that only the owners can change the current owner. And if not, then this line will get executed and the smart contract transaction will be completed. But if this fails, then the whole transaction will be rolled back and whatever money was cost for this transaction will be also reverted back in terms of gas fees. So how do we test this? It's pretty simple. We go to our compilation phase and we choose this and we click on compile. So let's see how it goes with the compilation. So if we check the messages, it looks like it did compilation successfully. So now let's go and deploy the smart contract. So make sure to choose the right one from here. And for deployment purpose, what I will do out of this, I'm going to choose this one. And I will deploy this. So now the address of the owner, the message.sender will hold this particular address, which is 0AB8. That's the one who is deploying. So now if I go here and check my deployed contract and try to get owner, I should see the same value 0AB84. So if you see this, it's same as 0AB84. So that's the current owner who deployed it. So now what I'm going to do, I'm going to change the owner to, let's say, the first one, 0x5b. Copy this and I will put the value here because this is the parameter it's going to take and this parameter is going to get passed here in this. So I will call change owner. And if I go and check now, what it says is only the owner can change the current owner. That's what it says. What happened? So when we use the first value, which is this one, that is currently the owner. So only this can change the new owner, but we were using a different address. So now if I change it back to the one which was the owner and try it now, we see that it did change the owner. So let's click on now this. So we see that the owner is now changed to 0xb. So you just saw that how we can also handle the error. So if the if the person who was trying to change the owner was not the owner, we got an error stating that like this, something like this. Only the owner can change the current owner, and the transaction was reverted to the initial state. And what was the initial state? The initial state was this guy, this address, which was the owner or the sender was the owner, so that was changed back to that level. And after that, when we just try to copy this address and try to change it here, it was allowed to change the owner. So in this way, we can define now the address. We can define constructor, which will get called only once. And then we can also call a function from outside, pass the address, and we can apply some validations. And if validation fails, the user is going to get this error, and then of course the transaction is rolled back. But if upon successful, uh, if the validation is successful, then the state is changed, and the state is here change is just the new owner is being assigned to the owner. So this is how you can write a nice constructor and function and call them via the deployed contract, and then in the deployed contract you can pass value and run them. Thank you. I will see you in the next video. Let's look at a concept of payable constructor. So I'm going to create another file here called payable constructor and view function. So again, we are going to copy the pragma header, which will tell the compiler to use which version of Solidity to compile this smart contract. So I'm going to say contract payable view, some doesn't matter, anything you can give any name. Now what I can do is I can create a constructor and make this constructor as payable. Alright, what does this mean? Let's quickly go and draw and understand. In the cryptocurrency world or in the blockchain world, everything has an address. So if you hold a wallet like this, which we already saw, there are different wallets here. So all of them hold address, and the address holds Ether. Ether is the native cryptocurrency of Ethereum blockchain. So if we go to this nice website, which is CoinMarketCap, you will see these are different blockchains. And we are talking about Ethereum as a blockchain network. So the native cryptocurrency of this particular network is called Ether. And 1 Ether is equal to 10 to the power 18 Wei. So Wei is the cent or the penny you can call when you're talking about $1 equal to how many pennies. Similarly, 1 Ether is equal to 10 to the power 18 Wei. So what we are seeing here is right now the cost of one particular Ether is close to $3,000, approximately $3,000. So here what we are seeing, this Ether is, all these are addresses which are holding some ethers. Of course, they are fake ethers, but on the actual real network, one ether is going to cost you this much. So if we want to execute one smart contract today on an Ethereum network, it is going to cost us some gas fees in ether. And we have to pay the equivalent of Ether in dollar to make the transaction happen on the Ethereum blockchain network. So now, who all these Ether are in the address. So some addresses can be of a smart contract itself or of, so this is, let's say this is a smart contract. This can also have an address, address 1. This is a wallet. This can also have an address, address 2. Even the cryptocurrency exchanges that we have, the different cryptocurrencies exchanges, they also have address. That's why we are able to send them different kinds of cryptocurrencies like Ethereum. So now, if we make a constructor as payable, that means we can send ethers to this particular smart contract. So let's write it down. If we have a payable constructor, then we can send ether to this smart contract. Now this smart contract can hold the ether. Alright, perfect. So the exchanges that you see, different exchange across the different, those are helping us transact different cryptocurrencies. They all are holding ethers or different cryptocurrencies, which means definitely somewhere in their code they have a constructor with payable. So now let's go ahead and write a function to check the balance of this particular smart contract. Whenever now we said this smart contract can hold ethers because we made the constructor as payable. So at any point of time, if we want to check the balance of this smart contract, how can we do that? Let's do that. So I can say check balance. We will create a public function which returns uint 256 because we are going to return an balance which will be of type uint. So we'll say return. So we can store it like this. I can say uint 256 balance is equal to, I will say address, which means it will give the address of this smart contract. If I do this address dot this gives us the address of the smart contract itself. Gives the address of the smart contract where this smart contract is located on the network. We will get that address. Now we want the balance at this address, so we'll do balance. Now we want to return this balance. Return this balance. Okay. Now this is a good function. There is no problem about this. But then we need to, while checking the balance, we are not changing the state of the network, or we are not changing any variable. So if we don't change the state of the network, blockchain network, or we don't modify any variable in our smart contract, then we don't have to pay any money. So how can we tell the blockchain network that I am just not going to change the state, I'm just going to view the state of the network or the view the state of the smart contract? So for that we have this keyword called view. So as soon as I put view here, here we are saying this function is not going to change the state of network or change the smart contract. Because always remember, whenever we want to change the state of the network or our smart contract modifies the state of the network, then there is some calculation or computation involved. And once the calculation or computation is involved, there are different parties who does the actual validation and we call them as miners. Let's say this is our blockchain network and we have this smart contract that we have written and we want to execute the smart contract to modify the state of this particular block. Then whatever is in our smart contract will be first validated by miners. So miner 1, miner 2, miner 3. All these miners are supercomputers, big computers who are going to take the contract and they are going to validate it. And they are the ones who are going to execute this particular smart contract logic on the blockchain network. So they are using their computation capability, the energy and power and their computers capacity they are using to execute our smart contract. So whatever gas fees that we will pay to run our smart contract here, that particular gas fees goes as an incentive to that particular miner who has executed our blockchain, our smart contract on the blockchain. So it's like if I am the particular person A wants to is the owner of the smart contract, then person A pays the gas fee, and if miner 3 is the one which executes this smart contract on the network and the network state gets changed, then the miner 3 gets this gas fee in ether as incentive. So this process is called mining. So this smart contract was executed by miner 3, but if there is another smart contract, let's say B wants to execute on the blockchain network, it may be executed by miner 1. So miner 1 this time gets the gas fee from B. So it's a competition that happens between the miners. Whoever first executes it, that particular miner gets the gas ether fees as incentive. So here, when we say that this smart contract is in the view mode, then we are saying that we are not going to update the state of the blockchain network or modify anything. Our smart contract is not going to modify anything. We are just going to view certain data of the blockchain network. In this case, we don't have to pay. We don't have to pay whether it's A or B. Don't have to pay ether as gas fee. It because it's just a view kind of or read only kind of behavior. So that's what we are saying here with the view that you don't have to pay money. So we don't have to pay any gas. So now let's go ahead and try to deploy this particular smart contract. So first compile this. So now it's compiled. Let's deploy it. This is the one. We'll deploy it. So it's deployed successfully. So if I go to this one, I'll minimize that smart contract. I will go to this one. I can check the balance. But now let's send some money because now we made our constructor of this smart contract as payable. So we can send some money to this smart contract now. And we can send the money in terms of ether. And this is the unit of way. So I'm going to just send 2 Ether, which means I'm sending as of today some $6,062 to a smart contract address. I'm sending this money, and here the smart contract is doing nothing but just checking the balance. So let me deploy this. So this is deployed. So I'm going to go now here and click on check balance. So if I check the balance now, I get the data back in way. So if you see now, I sent 2 Ether to this particular smart contract and I got 2 into 10 to the power 18 way. And if you remember on Solidity, there is nothing for specifying the decimal value. So everything gets calculated in the form of uint. So this is how we specified 2 ether, which means 2 into 10 to the power 18 way, which is the smallest unit of ether. So with the help of way, all the calculation happens. So there is no decimal point on Ethereum network. Hence, there is no data type for specifying the fractional part of an ether. So now you understood how this particular transaction happened. So we sent some money from an account, this account, to the particular smart contract, which is payable view, and then we were able to view the balance without having to spend any ether because this is just a view transaction. But now what happened is we just sent $6,000 to a particular address or the smart contract which did nothing. So there's no way to get back that 2 ether or $6,000. Of course, this is a test network, so it doesn't cost any money. But just imagine if it was a real network, I would have already lost $6,000 because just sent it to a smart contract address and that smart contract was dumb. It was doing nothing except checking the balance. So we have to be very careful when writing a smart contract and we should thoroughly test our smart contract before deploying it on any blockchain network. That's why as a blockchain developer, you have to be really, really careful how you write your smart contract so that there should not be any bug. Because once you have your smart contract written, you pay money for doing executing this smart contract on a particular blockchain network. You pay the gas fees of that network. For Ethereum, it's Ether. And then the miners take your smart contract and execute it on the network and they change the state. And once the state of the network is changed according to your smart contract, it's irreversible, it's immutable because blockchain cannot be changed. So in this case, I just lost $6,000 in thin air because there is no way to get it back. Hence, it's very important to write a bug-free smart contract as a blockchain developer. Thank you. I will see you in the next video. Welcome back. Let's go ahead and compare what is a pure function and what is a view function. So I'm going to create a new file. So that's from here. I'm going to say pure view function. So I'm going to say copy the pragma and I'm going to say contract pure view fn function and I'm going to say uint 256, not unint, uint 256 and I will say uh, num1 equal to 2 and uint 256 num2 equal to 4, and I am going to say function add, and what I'm going to do, I'm going to make it as a public function, and I'm going to say view. So I'm going to now say it's going to returns a uint 256, and I'm going to say return num1 plus num2. Now if I deploy or compile and deploy this, so let me compile it, and I'm going to deploy this. So I go here in the pure function and click on add. So I get 2 plus 3, 4 is 6. So if I call this from my local node, then I'm not going to pay any money. But if I call this view function from a blockchain network, then I'm going to pay way less money because this is not changing the state of my blockchain network. I'm just doing some calculation, but it is just on my own. I'm not doing any modification here. But if I'm going to say like this, function, let's say uh, do something, and here I'm going to just say public pure, and this function returns u int 256, and here I'm going to just say return 1 plus 1. Then this function here, what I'm doing now is this function is a pure function, so it's not doing any change to the state. So if we have a look at it closely, it's different than what we are doing here and what we are doing here. So if we get rid of this and we just say we are going to return, let's say num1, and I'm going to say some function, let's say. So what I'm doing is I'm returning or viewing the data of or the state of a variable. But here I'm not doing any change to or not even viewing the state nor even modifying the state. So let's call it that way. So pure function don't view neither modify the state of the network. So that's why they are called as a pure function. But view functions are used for viewing purposes only, and they don't modify the state of the network. So always remember, calling these functions are from our local node is not going to cost us any money. But if we are calling these functions, let's say from within of a smart contract, it is going to cost us money, but it is not going to cost that much money uh, as like a normal function would, because the normal function will go ahead and try to modify the state of the contract and then overall state of the network, and then the miners will be involved, and that's where you have to pay money. So in the blockchain world, it is very important to wisely make the function view or pure and save cost of your transaction. So this is it for this video. Thank you for watching. Welcome back. Let's talk about events and modifiers in Solidity. So for that, I'm going to go back to my folder learn and I'm going to create another file called event modifier demo, something like this. And here I'm going to create a new function. I will close the previous ones which are not needed. So here I will say pragma. So let's create a contract. I will say event modifier contract, and now I'm going to create an event. So what exactly is an event? Event is something that can be emitted or thrown from a particular function. So whenever an event is emitted, then that particular event gets seen or it becomes visible in the transaction. So what we want to do it now is we want to create an event. So that's how you create an event. Event log user and transaction. What I'm going to do is I'm going to pass the address, let's say, and the address will be user address, and I'm going to pass the uint value, which will be the amount of ether that we are going to transact. So this is the type, so it should be uint. So we have now created a event, and what this event is just going to do is it's going to print the address of the user address, who is sending the money or the ether, and the amount how much ether is sent. So now what we will do is we'll create a modifier. And what is a modifier? Modifier is similar to a function but with a special keyword. Say, so here I will say only to ether. So here what we are doing is we are going to trying to put a restriction that we can only send two ether. Of course, modifier can also take arguments, but for now we will keep it simple. Later we are going to see the arguments. And here I'm going to add a validation, say require, and I'm going to say message dot value equal to equal to 1 ether. And what does this mean? Semicolon. And the way we end the modifier is by underscore and then semicolon. So we'll say this is how we end a modifier, and here we are saying message dot value holds the amount of ether. So now whatever is the amount of ether that will be sent will come as part of this message dot value, amount of ether that was sent. Next, 1 ether means 1 followed by 18 zeros, because 1 ether is 1 followed by 18 zeros way. That's what we know from here. If we go here, we know that. So this is the shorthand to write 1 ether. 1 ether. So if I want to say 2 ether, then 2 ether. So here we are saying allow only 2 ether. So in the message dot value, like in the message dot sender, we got the address of the user who was executing or deploying this particular smart contract. So message dot sender has that address, but message dot value has the amount of ether that was sent. So what we are saying is if the amount of ether is 2, then it's fine, else we have a problem. So what we will do now here is I'm going to create a function. I'm going to say function send ether, and what I will do, I will make this function as public. I will say payable, so that once we make the function payable, we can basically send the ether to this particular address. So now we will apply this modifier to this particular function. So what is a modifier? It is a mini function which gets executed when a bigger function is executing. So when this function will get executed, it will execute this modifier. So that's why it's useful. So now from here we will emit the event that we created, and in the event we are going to pass message dot sender and message dot value. So what will happen now is as soon as this emit will happen of this particular event, then this will come into picture. But before this gets emitted, this modifier will get executed, and once the modifier gets executed, this is going to be checked, and if everything is fine, then we will have this transaction here logged. So let's go ahead and deploy this. So I will compile the smart contract, and then I'm going to minimize all of the smart contract that we have, and I'm going to deploy the event modifier contract. So now this is deployed, event modifier contract is deployed. So let's go ahead and try to send, let's say 1 ether. We'll see what happened. Let's go and check the logs. So what we see that when we try to send 1 ether here, we got an error. So if we go further up, we can see more, and the transaction was also reverted. But let's say as per the condition, if I send exactly 2 ether, then this should pass. So let me send 2 ether. So the message dot value will become now 2 ether, and I'm going to click send. So now let's see what happened. So as soon as I do send, if you see what just happened is we had a transaction, and the value was this. This was the previous transaction, and let's check the current transaction. Something is not right here, because what we expect is we should get a log statement here. This log user transaction should have been printed here. So if we say here log user, we don't see that transaction being printed here. So here it says logs is not printed here. So that's not good. Maybe we need to deploy with 2 ether first. So I will put this and deploy. Maybe put this and deploy. So there is some issue with the transaction because this is not working as expected. So let's quickly check this in the next video how to solve this particular problem. Welcome back. So after debugging a little bit, what I found is the problem was that this particular address that we are using here, let's say this one, did not have the sufficient ether. So if I put 2 here now, there is no sufficient ether here. So if I take this one and try to send this, there is no ether. If I take this and try to send this, no ether. So if I go with this one and try to send this, let's say one, if I go with the top one maybe, and I try to take this one, two, and now if I try to send the ether, you will see a transaction goes successful now. And if I click on this, you will see from address is this to address was our smart contract address because we made it payable and it took the gas fees this much, transaction cost as this much, and we got the logs here. And in the logs, what we see the event that we had. And in the event, what we did is we were capturing the user address, the address that we of the transaction itself, who executed the transaction. So if we go up and we see this is the address 0xab8 who executed the transaction, and that is exactly what we are seeing here, the same address. And we sent 2 ETH, and we that's what we also saw 2 ETH. Let's say now I will try to send only 1 ETH ether and send. So we'll see an error because we are sending less ether, and that because it was not a successful transaction, so it got reverted and we cannot see the it got reverted, we cannot see the logs. But as soon as I change this to 2 ether, so now we don't have sufficient balance here in this account, so I will go to this one and take 2 ether, let's say. Maybe this one has some ethers left. So 2, and if I send it now, I see that the transaction has successfully executed and we get this nice log. Perfect. So just keep an eye that if you have sufficient balance or not before executing. So now I'm going to close this. I will close the other ones. So let's now look at an example of passing argument to the modifier and how it works. So if we want to pass argument to this, we can just say uint 256 and then I can say amount, and I can go ahead and pass that from here. Let's say I will pass 2 or 3, whatever. So in this way we can pass argument to the modifier. So I'm going to I get rid of this, but this is how you can pass arguments in real world, and then you can use that argument value to do anything that you want in the modifier. So this is it for this video. I will see you in the next one. Thank you. Welcome back. Let's talk about 2 different types of variables. One is the memory variable, another is the storage variable. So what's the difference? So memory variables are those variables which are temporary and they basically disappear once the program execution is over. So they are not persisted, so they are just temporary. Next is they if they are not persisted in the network, they are temporary, so they are not taking part in the mining activity that the miners do. Hence, the memory variables are actually cheaper for you. If you use memory variables for writing your programs, then they are cheaper, less cost. Similarly, the storage variables, on the other hand, stay on the contract or the network. They are acting as a state variable and they are permanent, they get persisted, and they take part in the mining activity from the miners. Hence, if you are using more and more of storage variables, it's going to cost you more money. So it's more cost. So it's very important for you to remember when to use memory variables and when to use storage variables. So we are going to take a look of this difference with the help of an example so that you will better understand how exactly they both react when we use them in our contract. So let's go ahead and do that in the video to see the difference. Welcome back. Now I am in my remix editor and I'm going to create a new file called storage variable storage memory variable, and as usual we will take the pragma part from our previous contract. We can use the latest pragma also, which is I think 11. You can get it from here when we go for the compilation. So it's 13, so I can go with 13 also. Maybe I will try with 12 now. Let's not use the latest one completely, but the one minus latest. So this is how we can use that. And I will say contract, and I will say storage memory var contract. And what I'm going to do is I'm going to define a uint of array, and this I will say it as public, and I will say num array. So remember, whatever we define on this contract level, this automatically becomes state variable. These are called state variables or contract variables because they take part in the transaction and they change the state of the network or state of our contract based upon the transaction. Hence, they are called state variable or contract variables. Now, what I'm going to do is I'm going to just create a function. Let's say operate, and I'm going to declare this function as public, and I'm going to just go ahead and modify this array. Basically what I'm going to do is I'm going to push some item to this array. So I will say 10 and num array of push 11 and num array dot push 12. All right. And now what I will do is I will create another array. So I will say uint. By default, this uint is going to become uint 256. And I'm going to say now new num array. And I'm going to declare this as a type of storage variable. So I will say storage. And here I am going to initialize this with the num array. And now what I will do here in the new num array of index of 1, instead of 11, I will try to override its value to, let's say, 111 or something unique, let's say 15. So what I'm just trying to do is I declared a storage variable. I declared a state variable first, and then in the state variable I kept some value. Let's say 11, 10, 11, 12. This was an array, so I can put the values. And now this is a state variable, state, S-T-A-T-E, state variable. Then I declared a storage variable, and now in this storage variable I assigned this value, state variable. Basically now the storage variable and state variable are pointing to the same address. And now what I did, I tried to change the value of this from the storage variable. Let's see what happens. If we now go and compile our program, so compilation complete. Now we will deploy our program. So it's deployed. Click here. And now what I will do is I will click on operate. So it's going to push this data, and then also it's going to do this operation as well. Let's quickly do that. So click on operate. Execution complete. Now we will try to get the value of what was the index that we tried to change? 1. So on the index 1, let's see what is the value. So we see the value stored in the index 1 is now 15. It should have been 11, but then that value got overridden because we did an override here with 15, which means these state variables, or you can say the storage variables, especially the storage variables, these storage variables are permanent and they have effect on the network. We just saw that. So it's having effect on the network, on our smart contract. So our smart contract is getting impacted with this particular storage variable. So we have to be very careful when using this storage variable because these are costly, and any operations to this is going to cost you gas fees. So now what I will do, I'm going to just change this to memory, and other things I will leave it as is. So what will happen now is as soon as I change this variable to memory variable, then there will be a new copy created which is not going to impact this. It's not going to do this. No, a new copy will be created, and this is not going to have impact on the state variable. So let's go ahead and try it out. So I'm going to compile our smart contract again because we modified it, and then I'm going to deploy it again, and now I'm going to use not this version but this version of the smart contract, and I'm going to click on operate. Let's see, everything went well, and now if I try to access the index of 1, it should give us 11. You see it gave 11 because this memory variable is scope only exists until the scope of this function, and it cannot have impact on the state variables. So these kind of memory variables are cheaper if we go with the operations that we want to perform as a temporary purpose, and these operations are not going to impact the network. So always go for memory variables because you don't have to pay a high gas fees for using memory variables because the miners are not getting involved here. So hope now you know the difference between the storage variables and the memory variables and how to use them, when to use them, and what are the complications involved if you use too much storage variables you know it is going to increase the cost for you, the overall gas fees. So thank you for watching this video. I will see you in the next one. Welcome back. Let's go ahead and talk about what is the roadmap ahead for you to become a perfect Solidity blockchain developer. So the first thing that you have to do is you need to learn a framework like Truffle or Hardhat. So Truffle or Hardhat, they both are frameworks that help you develop, deploy, and test your smart contracts faster. Of course, we can go ahead and write smart contract in a Remix Studio or elsewhere. But then if you want to build a smart contract which is robust or bug free, then you must go for learning a framework. Make sure that you use one of the framework for the reason also that you don't want your smart contract to have any bug, so it has been tested thoroughly. And this framework provides that capability to you. You are able to test these smart contracts in your local simulated blockchain environment and test it there. And once you are confident, then you deploy it to a network. So that's the power it is provided with these frameworks, Truffle and Hardhat. So it's very important to understand your blockchain network is immutable. So anything that you do there is not going to be rolled back. And everything costs you gas fees or the transaction money. So it is very important you do a thorough testing of your contract, what it does in your local environment with these frameworks like Truffle or Hardhat. Well, Truffle is quite old. Its documentation is available readily everywhere. Hardhat is kind of a new framework, but it's also gaining momentum. So you can choose to learn any one of it. So if you ask me how much time it will take for learning any of these frameworks, so somewhere between 1 to 2 weeks you can invest learning in Truffle or Hardhat. Next, you should learn one of the front-end libraries or frameworks for building UI because as you know, once you have built and deployed your smart contract on the EVM, you need to build a front end for the end user to connect to your smart contract and do transactions. And they will be able to do that if you are using a front end framework like React or Angular or Vue to build that UI. And from that front end, you are able to connect to your smart contract via libraries like Web3.js or Ethers.js. If you ask me, my recommendation would be to learn React because a lot of ready-made tools or libraries are available for supporting React at this moment. And how much time you will need to learn React? It could be somewhere between 2 to 3 weeks you should spend learning React. Then go for learning Node.js and NPM because when you are building a smart contract application, you might also want to store some data of the smart contract. You only store those information on the smart contract which is really important. Other information you should not store on smart contract because otherwise it will be too costly for you and your smart contract will be costing you too much money. So other information you would like to store in a database and hence you want to create an API backend application which will talk to your API and then your front end can talk to your backend. So that's where Node.js helps you to build those APIs with frameworks like Express. And NPM is a package manager on top of Node that is going to help you install lots and lots of readily available libraries for not only for blockchain solidity libraries but also other libraries. Hence, it's important to learn this. It can take you around a week to learn Node.js and NPM. Alright, after you have learned all this, then the next step should be to build your own dApp. What is dApp? A normal application is called an app, but when you build a distributed application, it's called as dApp, D-app, distributed app. So you can take any use case. There are many use case available. You can build a DeFi application. You can build your own cryptocurrency. You can build an NFT game. You can build anything. Take any use case and build it on yourself, on your own, and then you will be already a good blockchain developer with Solidity and Ethereum. So this is the roadmap that you would like to look at becoming a good blockchain Ethereum developer. Thank you.